Yo, what's up, Internet? This is Sinus Media. Yesterday, I released quite a long tutorial on Sonic Pi and creating chord sequences in Sonic Pi. And I had some ideas for how I was going to expand the code I wrote yesterday to allow us to add some more chord types. And I've got to admit, I just got so enthused that I started playing with that this morning. And I realised I was more or less ready to talk about some of that. So let's get on with it. This is going to be quick. This is not going to be another hour one. If you didn't see yesterday's, then, well, I'm going to put a link in the description, and it might be necessary to watch that to make sense of what I'm talking about today. What I'm talking about today is very much a continuation of where yesterday's video left off. But if you're already fairly familiar with Sonic Pi and fairly familiar with music theory, this video might make sense by itself. So here's where we are kind of. We've got this loop. We've defined a function called Chord Sequence or Chord Seq, and it helps us compose music just by giving, basically we call that function, we give it a root note or a tonic. What key are we currently in? Let's say C. We tell it which mode, so major, and we give it a sequence of numbers which represent the chords of the degree, the first chord, 6th, 4th, 5th. So 1, 6, 4, 5, classic pop music thing. We're sending it via MIDI to FL Studio. And you can see there, it's just playing those 4 chords. So yesterday we added a bit of extra functionality to that. We can add whatever chords we like. Let's try a 1, 6, 3, 4, 2, 4, 5, 2, 3, 5. Let's see how that sounds. 2, 3, 6, 5. Not bad. We can also add we can make 7th chords by just putting this 7 on the front of the chord name or the chord number. I'm not sure I like that entirely. Perhaps not the most exciting chord sequence, but also we can put them into the minor just by changing that. So that's where we got to yesterday. Today we are now going to add a couple of extra features to this. First thing, I have to apologize for yesterday's video. What I notice is that when we are in the dark mode for this editor, this is Sonic Pi, and so color text on a black background, this cursor that I'm waving around was getting lost a bit. So I'm going to put it in the white background today. And hopefully when I'm pointing at things with the cursor, it will be easier to see what I'm pointing at. So here is our function. The way the function works, I went over this in more detail yesterday, but here's the short version. Each of these degrees of the scale, in other words, first degree, second, third, fourth, fifth, sixth, seventh, we've got chords on them like that. Each of those may be a major chord triad, may be a minor triad, may have some other shape like a diminished. It depends which degree you're at, which shape fits the current scale we are in. So these arrays here are the place where we look that up. In Sonic Pi, these colon capital M and colon lowercase m, colon dim, dom7, these are the various names of the types of chords, but we're putting them here in a kind of lookup table, in this array as a table, so that when somebody asks for, say, the 7th of the 3rd degree, they're going to, and we are in a minor scale, we're going to come to this minor key 7s, we're going to look up the 3rd degree and find out which type of chord we use for that 7th. In this case, it's a major 7th. That's the kind of music theory that's encoded within this chord seek function. The rest of this function, we now, because we're sending a whole sequence, a whole list of chords, we're just looping through that list here. We call them deg for degree. We're doing a case statement, standard Ruby case statement. When the numbers are just the ordinary 1 to 7, we're getting the triad of that degree, and I've decided to use this notation that I call them 73 or 75 or whatever for the 7th of that degree. So we go from 71 to 77. It's slightly strange to use that notation, but it makes the programming very simple because I can just use an ordinary numeric range. So now I'm going to add 2 more pieces of functionality to this. And the first piece of functionality is sometimes we do what's called modal interchange. In other words, we're using a minor scale. The key signature is C minor, but we might want to borrow a chord from C major as opposed to C minor. So that gives you a different color, a different flavor of chord. It's got notes that are not in the scale of C major, but it's a related one, and so it's not too radical a dislocation that kind of just sounds arbitrary. Modal interchange, borrowing, when you're in minor, borrowing a major. I mean, we already have major chords in the minor scale and minor chords in the major scale, but by doing the interchange, we actually take the equivalent that would be, so if we're in the major scale, we want to take the equivalent from the minor and vice versa. There's an easy way to do that in code, but we are going to just do a little bit of refactoring this. At the moment, this chord seek function does everything that we want. It's doing both the actual finding the appropriate chord for us, but it's also doing this looping to build the whole sequence. So one thing I want to do is I want to just refactor this to break it into 2 parts, which will make the rest of the coding simpler. Define, I'm going to call this just one chord. So we know that based on, again, we're still using the tonic, we're still using the mode. So the tonic is what key we're in, the mode is whether it's major or minor. And now instead of giving it degs, a list of degree values, we're just going to give it a single one and the end there. So now we're going to pull most of the useful logic from the chord seek up into the one chord. So this case of the degree, we can pull all of that up into here, and now all we're going to say then is we're going to give it 1 degree and we just want 1 chord back, so we're just going to return the chord that we created. That's it. And now in this part, the chord seek is doing nothing but running through that list of, in fact, here's what I'm going to do. I'm not going to append it here. We're going to do the appending at this point. We're going to say the chord equals now the call to 1 chord with the tonic, the mode, and deg. And now we're just going to put that into this short array we were using to store these things, where every step of the way we have the tonic, we have the mode, we have the chord. So a small piece of refactoring. This is not meant to change any functionality at the moment, but it's made it a little bit more convenient for us to make further changes, and you'll see how it's useful for us to do that. Let's just run it again to check it's working. So it's doing exactly what it was doing before. It's just that we have broken out the logic of defining a single chord from the logic that runs through and turns the list of degree numbers into the list of chords with this stuff. Now, why is this useful to us? Well, it's useful to us because one thing we want to do is we want to have the option of doing the modal interchange. Now, one of the questions I'm always working on here is I'm kind of developing this notation. What would be a convenient notation for me to use to represent all these chords? I mean, I'm partly talking about music theory, but as I said in my previous video, I find, for obvious reasons, this is not a criticism, but music theory is full of terminology. It's full of rather complex and verbose terminology. And I'm a programmer. I'm also interested in live coding. I'm using a system here that is meant to be make it easy for me to play with these chords, to access this stuff. I don't want a complex way of having to express this. I mean, programming is all about finding convenient ways of expressing complex things by not writing too much. I mean, that's the art, that's the joy of programming in many ways, is about that. So I want a convenient way to be able to say, at this point I'm doing some interchange. I want to switch from major to minor. So I've decided that a very convenient notation for me will be to just make the number negative, to just say, if I put a -2 here, instead of having I'm in a minor mode. The key is C minor. When I do -2, instead of pulling out the degree 2 triad from C minor, I'm going to pull out the degree 2 triad from C major. Okay, so that's how I've decided my notation is going to be. Similarly, -4 will mean swap. But if I was in C major, then -2 would be pull out the 2 triad from C minor. So you might think, well, that's slightly strange, but it's very convenient. It's very, very quick for me to write it. So I can play around and try how it sounds, right? It's very convenient. And it's also very convenient for me to implement. And you will see exactly how easy it is for me to implement right now. So here I have my one chord function, and the number that's coming in is this deg. It's deg for degree, but as we've already seen, we do some tricks. Like 73, there's no real degree 73. 73 just means the 7th chord of the degree 3, and we've handled that in this clause. But this is going to be even easier. We're just going to say literally, if deg is less than 0, which means it's negative, then, right, instead of going through and doing the rest of this stuff, we're just going to recursively call the same one chord function with the same tonic, but just reverse the mode. Okay, and we're going to give it the same. We're going to give it minus the degree. So if we get a -2 in here, all we're going to do is we're going to invert the value of mode. We're going to return the value of calling this function again with the mode inverted and the degree negated. So the -2 is going to become a 2. And how do we do that? We'll just say if mode equals major, we'll do another expression. Can't think of the name of it now. But anyway, the mode equals major, then we're going to send it minor. And if it is already minor, we're just going to send it major. So this expression, conditional expression, that's the term I was looking for. This conditional expression here just says, if the current value of mode is major, this expression will evaluate to minor. If it's currently minor, it will evaluate to major. And that's the argument. So we're just literally calling this function again, inverting the mode, and the degree is going to be the normal number. That's all we need to do. So now, if we were to come here, let's just go back to a really simple one again, 11645. So everything is normal here, major, so you know what that sounds like. Let's just turn that into the equivalent minor from the sorry, the minor from the the fourth from C minor. And so what you'll hear is you've got a new type of chord and a new type of sound, which is definitely adding flavour to this. It's definitely, we've got notes that don't exist in C major. Okay, that minor has got a G sharp in it, or an A flat, however you want to describe it. It is A flat, isn't it? Yeah, an A flat. So it's giving us something from outside our key. It's giving us some colour. It's giving us something exotic, or a bit of more exotic. But it's not giving us something that's too random or too dramatic. It's a controlled sort of exoticism, and that's a lot of composing music with these richer chords is about that. It's about borrowing from similar or related or adjacent keys, so that when you take these extra chords, you are not, it isn't arbitrary, it is constrained, it is related, but it is different as well. It's giving you a controlled amount of exoticism. So that was really convenient. It was a very short bit of extra code that has given us this extra something new for our language, our way of representing sequences of chords. So the next trick we are going to do is we are going to add secondary dominants to this. So what's a secondary dominant? If you remember yesterday, we talked about the degrees. We have 2, 3, 4, 5, 6, 7. The dominant is the fifth, 1, 2, 3, 4, 5. So in the key of C, it's G. G is the dominant, and a chord on the dominant kind of wants to go back to the tonic, to the original. So when you've got this sort of tonality, you're in the C, key of C, and you hear that chord, the dominant chord, it really feels like it wants to take you back to C again. I mean, this is, of course, it's a slightly weird psychology if you think about it, because in another key, this is a completely different chord, and you don't feel it has the same need. It has this compulsion associated with it, but somehow the way we've kind of understood music, certainly the tradition, the European tradition of understanding music, is that once you've established that this is your main tonality, this kind of wants to take you back there. It's not. It's clearly cultural, and whether we feel this, how deep this is biologically, psychologically, culturally embedded in us, it certainly works. Most music really works on these sort of principles, and it creates these psychological effects on us. The way music affects us does seem, this theory captures something about it. How that really works deep down is a big topic. But anyway, there is our dominant, there is our tonic. When we hear this, we want to go there. It feels good, that transition, that cadence. So what we can also do is we could say, suppose we're going to a different chord. Suppose we're going to a chord like our D chord, our second degree chord. Well, imagine we wanted to make a transition to the second chord that felt as satisfying as that cadence from the dominant to the tonic. Well, we can come up with were this second chord to be our tonic of whatever our key is, what would be the dominant of that key such that it could lead to it? Okay, that may sound a bit convoluted, but think of it like this. There is a key which is related to our current key in such a way that let's say our second degree or our third or whatever it is in fact the tonic of that, and there is the equivalent dominant that would take us to that. And when we borrow that chord And that chord is the secondary dominant. The secondary dominant is the dominant in the key where the chord we currently want to go to in our key is the tonic. Okay? And so borrowing that secondary dominant is, well, I'm going to show you and you'll hear how it sounds. And when you hear it, you'll suddenly think, I recognize that move being made from many genres of music, and it sounds good. And the reason I think it gives you a great effect is that you're going to a key which is sufficiently close that, again, borrowing from it is giving you an exotic flavour, because you're definitely leaving your current key, your current scale. You have notes that are out of that scale, but again, it's in a constrained way, because you're going to visit that and it's going to then come back immediately and in a satisfying way to a chord which is in your key. So it's not, again, just a kind of a random excursion somewhere completely different where you're losing your sense of the tonality. It's a trip, but it feels like it's coming back. So that's very abstract, and if I were playing the piano, I would demonstrate it, but I can't demonstrate it. Instead, I'm going to demonstrate it with code, and I'm going to show you the code that does it. So I'm not going to type this in front of you because I would make mistakes and it would be longer and not necessary. So here we are back looking at one chord. I've now put into it the ability to add these secondary dominants. Again, because I'm always interested in the notation, I've added a notation that simply put a 26, for example, is going to give us the secondary dominant of the 6th chord. So here's how I've done it. I've made one other change. I've had to put the bit that calculates the chord inside the clause. So here we now have our standard triad chord, 1 to 7, and you'll see we calculate the root, we look up the appropriate chord, we build that chord here. Same with our 7th chords. Now I've added this clause for the secondary dominant chords. Now this is just a little bit more complicated. What we're doing with the secondary dominants, again, we've chosen the notation that it's going to be the numbers 21 to 27. So the 2 reminds us it's the secondary, and 1 to 7 again for which degree of our scale. So of course the first thing we have to do is we have to subtract the 20. Now we calculate what would be the root of that degree. Well, we're not going to use the root of that degree at the end, or rather we're going to take that root. Let's say we're talking about the 4th degree, so we're going to take of C major, so we're going to calculate that value, that F, as the 4th of our thing, but we're not going to build our chord here. We are now going to find what the dominant of that F chord would be. So here we call that the original root, and we call our degree function, it's the same calculation we did to calculate the root everywhere else, but it was just being assigned to this variable called original root. Now we just call it again. Now we say, well, okay, assuming that root, that original root was the tonic, and we want to find the dominant of that, and the dominant is always the 5th degree chord. What's that number? So that's what we've done. We've done the original degree calculation to go from our tonic and our degree number to get to the original root, to get, in this case, if it's say the 4th degree, to get that F. And then we've just done it again, but using that original root this time as if it were the tonic, using 5 as the degree, because these are always the dominants for that, and using the same mode again. And then we're just going to build the chord, and that's going to be our new root, and we're going to build the chord on that root. Now, what chord do we build? Well, we build a dominant 7. That seems to be a standard. So if you remember, the standard major 7th is like this. The standard minor 7th is like this. And the dominant 7th is a kind of mixture of the two. It's got, the first bit is like the major bit, and the second bit is like a minor bit. So it's half. It's not that, it's not that, it's that mixture. And that's interesting because that gives you a tritone. Does that give you a tritone? Yeah. So yeah. So that's a bit dissonant. It's got that kind of bite, that slightly acidy tang of dissonance, but it's also within a context that's a little bit more smooths it out a bit. And so we're introducing something a little bit dissonant and exotic because it's outside of our scale, our normal scale, but it's going to be so strongly connected to the chord we're going to take it to next that it will work well. So that is now what we added to, and again we just returned the chord. Again, it's literally 4 extra lines or 5 extra lines of code. It's really simple what we've done here, but it's going to enrich our vocabulary and our representation. So this has all sounded very abstract, I'm sure. So let's hear how they actually sound. Let's try something very simple, like a 1, 4, 6, 5 chord sequence. But now what we're going to do, remember, the best, or the way we use secondary dominants is we put them before the chord we're going to. So let's say this 4th chord, let's put a secondary dominant before that. And let's put a secondary dominant of a 6th before the 6, and a secondary dominant of the 5 before the 5, and perhaps we'll put the 1 before the 1. So we're interspersing before each of the chords we're going to, we're putting this secondary dominant to go to it. And also, because these get high, I'm going to put this down an octave. So let's hear how this sounds now. You hear how those chords really seem to fit well into the place they're going. You know, they fit well with what comes next after them, and they give you a bit of excitement. They don't instead of just going straight from each chord to the next one, they produce quite a lot of brightness, quite a lot of, a certain amount of exoticism. They are taking us out of our key. We're in a key of C major, and yet you're seeing various, there you go, a B flat or an A sharp, a G flat. And yet it doesn't sound completely bad or out of place. It's giving us, and I'm sure you've heard music that does this. It's got a sense of a kind of romantic music from the 50s and 60s. It's got something a little bit, I wouldn't say jazzy exactly. I mean, of course, jazz musicians use everything, so you'll hear that in jazz, but you'll hear it in various styles of music. It's a very useful flavour to have. Now, how does it sound when you do it in the minor? So now you get something that sounds almost very classical kind of effect there. Okay, we've got secondary dominants. Let's just go back and also bring them back together with some of our 7th chords we had. How will that sound for us? Smoother. So, in fact, you notice this 7-5 and the 2-1, they're almost the same. I mean, the 7th of the dominant, if you remember, let me rephrase that. The 7th, that's the 5th degree, already in the major is already a dominant 7th chord. In other words, already that one that's half major, half minor. So actually 75 and 21 here are the same chord, although we're getting there by slightly different routes. But yeah, you can see that now by mixing 7ths, mixing these secondary dominants, we're getting some interesting sounds. Let's also try the other thing. I found a chord sequence earlier, which I'm just going to paste in because I can't reproduce it exactly by memory. So this uses all of our new techniques. This is using 7ths, it's using secondary dominants, it's using modal interchange where we're in C major, but we are going to occasionally go into, we're going to borrow the 4th from the C minor, we're going to borrow this 7th. The convenient way about the way we've done this, of course, is that this, using the minus sign to represent the interchange of major and minor, it works with our 7th chords as well. It would work with our secondary dominants as well, because we just literally at the beginning here recursively call the same function. So any extras we do here will work fine. So here's what I came up with. It took a bit of playing around. It's using too many tricks, but I kind of like the sound of this. So we start off normally, alright. This use of a secondary dominant 7th gives us a slightly smooth, jazzy sound there. Another pair of 7ths give you some, but these are, here we go. So there's a shift from the major to the minor of the same chords. That makes it rather sad sounding. Then we go back up to our 7th dominant, which this kind of is a rather melancholy thing, but then we don't go any further down. We kind of come back up again, so we don't fall completely. That's a great, very jazzy sort of transition here. Now here, so yeah, that now you can see. Welcome to the. You can see the power of doing things through code. I mean, you might have kind of seen the previous video and thought to yourself, well, all right, I know enough musical theory. Why do I need to do this in code? Or you might have thought, well, I can just get chord packs, or I can just get, one of these plugins like Captain Chords or something that will just do all that for me. Well, yes, but when you're writing your own code, okay, you can start adding new ideas to it. You can start saying, well, here's another piece of music theory I've learned. I can just put that into my same function and extend my vocabulary of things I can talk about here. And this is what I'm doing. We may go on and add more to this in future videos. I'm very happy. It didn't take me very long to add this extra stuff. Of course, I will put this gist of this so you can play with it yourselves as well. But keep investigating, keep exploring, keep learning new bits of music theory, figuring out how you can code those as well and use those in your music. And of course, see what you can do with it. So that chord sequence I've been playing with today may not be quite what I would like, but here's what I did with it, right? So yeah, I mean, I added, that came out of some code where I also added a couple of extra random notes each time, and of course I'm playing on a more more complex instrument. I'm using Citrus Dreamy preset. I also put a little bit of automation on the modulation for that from formula controllers I had. So they're modulating it slightly. But nevertheless, you know, the main part of that is just in these chords that I discovered through playing around, and we all compose by experimentation. Of course, if you're already an experienced piano player or guitar player, you'll be kind of learning. You'll have learned these techniques anyway. But if you're still new to this, or you're kind of getting into, you want to use this in a live coding environment, then now we can have some quite interesting chord sequences. So thanks, that's what I got. That's the supplement that again has got long, but I hope it was interesting. And yeah, do go experiment, explore, bring as much, anything you can find. You know, YouTube is full of people explaining music theory these days, and some of this I just got from watching other people's videos and just took what they were talking about on the guitar or the piano, figured out how I would do the same thing in code. And of course, code is superpowers, because now you just have still a very short program, and we can think of other things to add to this. I'm thinking of how we're going to do chord inversions. I think Sonic Pi has got some help with that, but I haven't quite figured out how to notate it to my own convenience. But we'll get there. So thanks for watching, and there will be more videos. So do subscribe, because if you like this kind of stuff, as we're not going anywhere, I've got loads of ideas actually, some quite surprising ones.